All right, so let's look at the autumn 2019 test number 6. This is a parametric equations one in this test. They say x is given by this. As time goes by, the x coordinate varies as this thing, and the y coordinate varies like this. And we want to find the tangent lines that go through the point 5, 5. Okay, so first, tangent lines, we know we're going to find the slope. We have to find the slope. So the slope, dy dx, the derivative, right, the slope, is dy dt. You always know you put the y in the top because the dy is on the top here, and the dt's cancel, divided by dx dt. Those are easy derivatives. We take the derivative of this with respect to time, so that would be 6t squared, and the 3 goes away, so that's just 6t squared. And the dx dt, the derivative of this one, is just 2 times 3, which is 6t. So divided by 6t, which, look at that, all we have left is t. So the derivative, the slope, is always the time that the particle is at a certain point. So that's really nice. So now we have 2 points, when x equals 5, y is 5. So what time does that happen? So we can set when x equals 5, so 5 is equal to 3t squared plus 2. Okay, this is the x. What are the times when x is equal to 5? Well, let's see, take away the 2 from both sides. 3 equals 3t squared divided by 3. That would be 1 is equal to t squared, or it happens twice at t equals plus or minus 1 seconds. That's when it's at 5. Now, how about the y-coordinate? So when is the y-coordinate 5? So it's 5 when y, which is 5, is 2t cubed plus 3. Take away the 3 from there. We have 2 equals 2t cubed. 2's cancel. 1 equals t cubed. The only possibility for that is t equals 1, right? Because negative 1 cubed is negative 1 times negative 1 is negative 1. So only at t equals 1 second. So at t equals 1 second, which works for both of them, that's when the coordinate is at 5, 5. When t equals 1 second, the slope is 1, right? This derivative is 1. So the slope is 1, and so now we have a slope, m is equal to 1, we have a point 5, 5, and so now we just have to do the y minus y1 thing. So y minus 5 is equal to the slope x minus 5. Put that over there, y is equal to x minus 5 plus 5, or y is equal to x. So that is one of the tangent lines. Y is equal to x, and it goes through the point 5, 5. Okay, now you might think we were done, and unfortunately we're not, because this curve, okay, it goes through the point 5, 5. So like, let's say here's our curve, and this is the point 5, 5. Okay, so we found the tangent line to that point. We found this line right here. Y equals x is tangent to our curve, whatever it looks like. Y equals x. However, this is the really tricky part. They said find all the tangent lines that go through the point 5, 5. So it's possible that this curve somewhere else, like let's draw this curve somewhere else goes like this, and way down here is another tangent line, and it goes to the point 5, 5. Okay, because it's tangent to it, and it goes to the point 5, 5. So unfortunately, we have to find see if there's another point, and unfortunately there is. So we're not done. So let's call, this is a very bad picture, but hopefully you get the idea. 5, 5 is on the curve. We found the tangent line there. That's the easy one, y equals x. But another line can go through the point 5, 5 that's also tangent to the curve at some other points. Let's call that other point AB. Okay, so we got to figure out that point. What's another point where a line through 5, 5 is tangent to the curve? Okay, so let's do that. So what is the slope of that line? So the slope m is change in y, so say b minus phi divided by change in x. Change in x is a minus 5. Okay, that's our slope, and we know that the slope has to be equal to t from above. That still works, right? This always works. So that's got to be equal to t. And this is b then has to be on the curve, right? A and B are on the curve. That's the whole idea. They have to be on the curve. To be on the curve, they have to satisfy this relation. So B is the y value is 2t cubed plus 3, and the a value has to also satisfy that. So B then is the y, which is 2t cubed plus 3, so I'm going to say 2t cubed plus 3 minus 5. On the bottom we have a, which is the x value, which is 3t squared plus 2. 3t squared plus 2 minus 5, and that's equal to t. So now we just got to solve for the other t. What other time does this happen at? And then we can figure out the slope of this line. Okay, so we have to solve this. So let's see. First off, we can do the subtraction here to make our lives a little bit easier. So 3 minus 5 is negative 2. So 2t cubed minus 2 divided by, and here we have 2 minus 5, so that's minus 3. So 3t squared minus 3 equals t. Multiply both sides by this bottom part. I'm going to continue up here. 3t squared times t is 3t cubed. Minus 3 times t is minus 3t, and that's equal to what was on top over here. So that's 2t cubed minus 2. Let's put all the t cubes on this side. Let's put everything on this side. Minus the t cubed, minus 2t cubed. 3 minus 2t cubed gives us 1, so that's just t cubed. Minus 3t, the minus 2 becomes a plus 2. Plus 2 equals 0. Okay, so what time satisfies this? Now, this is not easy to solve, right? Things with cubes are not easy to solve. There are various techniques to do this. One of them, which this is on a final, okay? You can't use Desmos or something. This is actually really tricky. I don't know how, this was the hard one. My guess is on this final, very few people got this one right. Because first you had to see that there's another point. Personally, I would have stopped here and said, oh, there's only one, y equals x. But you forget that, but there's another possibility. It can go through the 0.55 and do that. So that would have threw off most people. And then you had to solve this. Now, one way to solve this is to guess and check. And it turns out they made it pretty easy. T cubed, so try 1, right? 1 minus 3 plus 2. Anyway, that's not going to work, so try 2. And it turns out if you try negative 2, it works. So let's try negative 2. So, you can look at this. It's pretty simple. If you spent a couple minutes guessing and checking, you could solve this. So negative 2 cubed is negative 8. Minus 3 times negative 2 is plus 6. Plus 2 equals 0. So yep, sure enough it works. Okay, so at negative 2 seconds, the particle's there. So what is the x and y value at negative 2 seconds? So the x value is 3 times negative 2 squared plus 2. Just going back to our original formula, at negative 2 seconds, what's x? It's 3 times negative 2 squared plus 2. That would be 412 plus 2. So I think that's right? So negative 2 squared is 4, 12 plus 2, that'd be 14. So that would be 14. And the y value is 2t cubed plus 3. So 2 times negative 2 cubed plus 3, which is, what's that? Negative 8. Negative 2 times 2 is, that's 8, but negative 8 times 2, negative 16 plus 3 is 13. Negative 13. Let me try that again. This is negative 8 times 2. This is negative 16 plus 3 is negative 13. Okay, so our point now is 14 comma negative 13. And our slope is negative 2 because the slope is t and t is negative 2. So our slope is negative 2. And now I'm going to see if I can do this in the bottom part of the paper. No, I'm not. You should always use lots of paper. So I'm going to try to set a good example here. Okay, so let's try this. So let's see, everybody. Okay, so we have our points again. 14 comma negative 13, and the slope is negative 2. So y minus negative 13 equals m negative 2, x minus 14. Y plus 13 equals negative 2x. Negative 2 times negative 14 is 28. It's 28. Yep, plus 28. Take away 13 from both sides. So y is equal to negative 2x plus 15, which hopefully is the right answer. Yep, that's what they got too. So this is the other line that is tangent to the curve, and it goes through the point 55, which again means that the point 55 is over here, but it goes through it and is also tangent. Okay, tricky stuff. Again, my guess is very few people actually got this line. They gave us a hint. They said the tangents, so you know there's another one, and if they say tangents, that means you got to look for the one that's off the line. So that was the hint they gave us. There's one that, yeah, that's tangent in a different place than at 5,5. Okay, tricky stuff. Thanks for listening.